Guys, you can see that this is our STM32H753ZI NUCLEO based board, and this is our LED blinking very fast because we have given it a delay of 100 milliseconds. So let me show you the code. This over here is our code. You can see that here we just used our GUI, and on the GUI you can see that we initialize that PC12 pin because on the PC12 pin our LED is connected, and then in the code what we did is that we wrote a command called hold GPIO write pin port C pin number 12, set it high. We set it high with a delay of 100 milliseconds. It remained high for 100 milliseconds. After that we wrote again the same command PC12 port C pin 12 to be set reset means to be set low for 100 milliseconds. So this is giving us this result that our LED is blinking with a delay of 100 milliseconds. See, guys, welcome to learning microcontrollers. In this video I will show you how we can interface a 5mm crystal type ordinary LED with the STM32H753ZI. We will be using STM32CubeIDE for the programming. So what will be the difference? Previously we used the onboard LEDs, these ones. We didn't connect an LED externally. So in this video I will show you how to connect an LED externally. So guys, this will be our STM32H753ZI. I have just flipped it upside down. Now this is the back side. This is our 5mm crystal type LED having two pins, one longer, one shorter. The shorter is the ground, the longer is the power. And connect the ground pin directly with the ground of your STM32. There are various ground pins on the back side, you can see. You just connect with any ground, all are common like this. For the power we will need a safety resistor. Just like normally, it can be of any value from 100 to 100 ohm to up to any value you prefer, but higher the value, the dimmer the LED will go. So I will use a 220 ohm. Connect the power pin to the one end of this resistor like this. From the other end, you may connect it to any available GPIO pin. So there are a lot of pins, but I will connect it with the PC12 because it is in front of me. So this will be our simple hardware. Now we will program this to blink this LED. So let's get to the hardware before we move on to the programming. So this over here is our simple hardware. Let me connect this USB port, its port, to my computer so we can do the programming. So here you go, it's connected. Okay, now we move on to our STM32CubeIDE. So there we go. I just turn it on. We wait for it to be turned on. Okay, this is our let me use a magnifier so you guys can see better. So this is the magnifier here. So this is the workspace. This will be like a main folder in which your projects will be created. More folders, subfolders will be created. So this will be the main folder, your workspace. So I just name it the workspace, no issue. Okay, wait. Remember to be connected with the internet whenever you are using the software because it keeps on updating itself. So here we go, we just turned it on. So first of all, click on file, click on new, STM32 project, wait. We have to wait. Okay, it has started some sort of update. So this tools keeps on getting updated, so you have to be connected to the internet. Just wait for it to update itself. Okay, here you go, it's starting up. Now see, it's doing something over here. I do not open it often, I just open it sometimes, so that's why it happens. If you open it regularly, then there is no such issue. So this window will pop up. You have to select the board you are using. You have both the option. Either you can go with the microcontroller, just write the name of the microcontroller on the board, or if your board is available, then just directly select the board. So the board have a commercial name H753ZI, this one. Okay, I write here, okay, this is the board. To make sure that this is the correct one, just read the description. Okay, that is perfect. That is exactly the same I have. I click on it and click next. Then this window pops up. Now this is the subfolder, like the project that first it asks was the main workspace. See, this will be the workspace, and then oblique then this folder will be created. So I call blink external LED tutorial. Okay, I click on finish. Wait, it is generating the GUI, may take few more seconds. Remember, you must be logged in. In my earlier video, I showed you that you must be logged in to use this. So you have to log in first by going to the help and then log in. Okay, click on OK. It is asking for the onboard components to be already initialized. So I have no issue. Just click OK. I'm not using these pins for my LED. Wait, the GUI will be generated soon. It keeps on doing a lot of things, keep on downloading a lot of things. You can see it over here. It will show you that what it's up to. So I have to wait. Okay, there we go. Okay, this is our GUI. Now on the hardware, you know, we have selected PC12. Now look for the, okay, we zoom in using this over here. We zoom in using our mouse wheels so it do not get spat. Okay, check for the PC12. Where is PC12 pin? PC12, keep looking for it. Port C, pin 12. So there we go. This is the pin. Now you have to click on it. Let me zoom in. Now you just left click on it, and here you set it as an output pin. Like in case of micro C or in case of Arduino, you set the port as output or the port as high or low. In case of micro C, the pin has to be turned low to be declared as output. And in case of an Arduino, you do the same to declare the pin as an output. So here the same you have to do, because we are connecting an LED, so we have to declare it as a GPIO output pin. So there we go. Now go to your project, click on generate code, wait, click yes. Here we go. Okay, the code is generated. Now you can see it has automatically done a lot of things for you. It have declared the header files, it have declared the clock and all the pins that we selected. See, these pins we didn't, that's why it was asking, like, do you want these pins to be initialized? If you said no, then he was not to initialize these things, but I have no issue with these. So in the while one, here we have to do our programming. So to do the programming, what we do is that we take help from the AI, because it's available and now it's easy to use. Go to your Chrome, go to your Google account, write down ChatGPT. The beautiful thing about STM32CubeIDE is that you do not need help from any document. You just have to go to the AI. It have everything. We are basically going to get the commands from here. I tell him that I have, now important thing is this, you have to learn how to write the prompt. I have STM32H753ZI NUCLEO board. I am using STM32CubeIDE to write the code. I have an LED connected to pin PC12. I want you to blink this LED for me with a delay of 500 millisecond. Okay, upload this. There you go. These things are automatically generated. You don't have to do them again. Only this is the thing you have to write. Now see, he is using the toggle command. I don't like this command. I will use the other command, set and reset. Instead of using toggle, use set and reset commands. Now it will change the commands as per my demand. So this is what I just wanted. So you don't have to copy everything, just copy what is inside the while one. This, copy it, go to your STM32CubeIDE. Now go to your while loop, go down, 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 down. There you have the while loop. There, write the code here. Okay, now this is the command to set the pin high. Like in case of Arduino, we use a digital write pin and then high. In case of micro C, we write port B dot F0 equals to 1. Here we use this command hall GPIO write pin. There, this is the part of the syntax. GPIO, select the port, port C, then GPIO pin, pin number 12. So it is C12. So these things you only have to change. And then GPIO pin set, this means that make it high, 1, send 1 to that pin. See? And then we give a delay. This is a delay syntax. Inside it you write the delay. Like in case of micro C, it's delay ms. In case of Arduino, we simply write delay. Here we write hall delay. This is the syntax and this is a delay in millisecond. And then again you use this command GPIO hall write pin, again port C, pin 12. Instead of setting it high, we use the reset. Reset means 0. See, 0 means turn the LED off. Then it keeps it off for 500 milliseconds. So this is our simple code. Now you can see the code has been written. Now what you have to do is that you have to click on this button called run. You click on run. It will check for errors if there are any. Wait, it is checking. Okay, now take a look here. It says 0 error, 0 warning. Now we can send it, we can burn it into our board. So for this type of board, you do not need ST-Link. You just have to connect it using a micro USB to the computer. Click OK. Click OK. Now it will burn it. Now waiting for debugger connection. Wait. It is burning it. Okay. Download verified successfully. So it's burned. Now we go to the hardware to see is our LED blinking or not. See, our LED is blinking. It is blinking with a delay of half a second. See, simple as that. You can use any pin for this. It is very easy to use this board with the STM32CubeIDE with the help of AI. See, okay, now we change the code. We play with the code a little bit. So instead of a delay of 500, I make it 100. I just make it 100. Both the delays 100. It will be on for 100 milliseconds and off for 100 milliseconds. Now it's done. I press Ctrl S to save it. Again, I click on this same green button, run. Wait. Okay, it is downloading. You have to wait. Now see how much easy it is, just like Arduino. It's very easy to upload the codes. Okay, it's done. The new code is uploaded. Let's go to the hardware. See, now the LED is blinking really fast. See, now this is a delay of 100 milliseconds. So guys, this is it. If you guys have any questions, you may ask. We'll see you in the next lecture. Goodbye until then.